On July 23rd, 2024, a hydrothermal explosion occurred at Yellowstone's Biscuit Basin. This explosion is extraordinary in that it was captured on film by tourists that were located right next to the explosion when it occurred. My name is Paul Day, and I'm a professor of geology, and I'm going to take you through the geology behind the headlines. So here are some of the headlines from the event that caught my eye. A hydrothermal explosion sends Yellowstone visitors running. Yellowstone eruption. What happened at Biscuit Basin? Could it happen again? A baffling, dangerous explosion in Yellowstone. What is a hydrothermal explosion? Pictures like this were frequently associated with these questions of this hydrothermal explosion. We're going to talk about this in this discussion. Is Yellowstone going to erupt? Questions rise after a hydrothermal explosion this morning. We will see if there is a connection between the caldera and the geysers that are in the area of Biscuit Basin, as well as what might be causing this explosion here. Yellowstone explosion update. Blast flung rocks up to 3 feet into the air. These are very large rocks. You know, for those of you that are unfamiliar with the U.S. system of using feet, this is just short of a meter, about 80-something centimeters. Yellowstone volcano scientist says black diamond eruption was quote-unquote small, can get much bigger. So yeah, that's not frightening, right? This is just a small one, and this was terrifying people. What is a hydrothermal explosion? Let's find out what happened at this pool and find out what we can learn from it and see if this is something that we need to be concerned about. So Biscuit Basin, which is where this hydrothermal explosion occurred, is part of Yellowstone's upper geyser basin, which includes the very famous geyser, perhaps the most famous geyser in the world, Old Faithful. In fact, it's only about 2 miles away. In fact, on this map here, which I pulled from Google Earth, we can see that Old Faithful is going to be located right here. You can see that there's a lot of human investment and activity all piled around it. This is a major spot for tourists to come in, and Biscuit Basin is located over here. And tourists will usually take this loop. It's a scenic loop that they could take around to look at geysers. And here we see Biscuit Basin. There's a parking lot over here. We'll get into that in a little bit. And one of the things I want you to notice throughout this basin, which is to say the upper geyser basin, of which Biscuit Basin is part of it, and Old Faithful over here, is that there's this grayish material deposited everywhere around here. This grayish material is from something called Geyserite. So the Biscuit Basin itself is named after Geyserite in an indirect way. So the name comes from the grayish white porous sinter deposit called Geyserite that can resemble biscuits. And so this is where we're seeing all the hydrothermal activity. If you see white, for the most part, there's hydrothermal activity happening in this zone. And so you can see it's one continuous zone coming across the entire map here. Now, this is not a very large area. 4,000 feet for scale is down over here to give you an idea. So this is about 2 miles across. For those of you that are more interested in metric, that's about 3.5 kilometers roughly off the top of my head. Geyserite is a common deposit throughout the upper geyser basin. So we see it everywhere in here. So now we have an idea that this is part of a very large field of hydrothermal behavior that is happening in Yellowstone.
Run, 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 run! Keep going. Run, 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 run!
At about 10 o'clock in the morning, there was a sudden explosion of steam, hot water, and rocks from Black Diamond Pool in Biscuit Basin. This was an absolutely huge explosion to kind of come out of nowhere. This was violent, it was sudden, there was no shaking that was happening ahead of time, so there was no real warning of anything. And it occurred adjacent to a crowded boardwalk. Here we actually see a photograph of that boardwalk, and we just saw video of people running on that boardwalk away from this explosion. In fact, this is a screenshot of people standing on the boardwalk just as the explosion really starts to clear its throat and to go. Rocks over 3 feet wide were ejected by the explosion. In fact, here we can see a rock. This thing here, if it was to hit you, would end your life. And so fortunately, that didn't happen. Nobody was hurt, but this was a really large, unexpected explosion in a place where, again, tourists are just walking right by it on the way from the parking lot, which is located on the other side of the explosion over here. In fact, these people are running away from their cars to get away from the explosion rather than towards the parking lot. So they've got to go right back past it again.
God, I'm shaking.
So once the explosion was over, geologists and scientists, as well as park workers, were able to come in and assess the damage to find out what had happened. Fortunately, nobody was injured in this event. However, the explosion did destroy a good portion of the boardwalk. You could walk across it, but it's pretty badly damaged. And so as a consequence, they shut down this boardwalk and this whole section of Biscuit Basin, not just because the boardwalk is damaged, but that is a big part of it, but also because they wanted to monitor the situation to make sure that it was safe. The water in the pool did continue to roil as the day went on. In other words, it picked up a lot of sediment. It changed color. Normally, it's that nice light blue color. And in this case, it had turned into this muddy gray color that you're seeing here. This is an image from a drone that had taken a photo shortly after the explosion had happened. This right here is Black Diamond Pool right here. Okay, this is another pool called Black Opal Pool. And over here, it's kind of buried, but is it's called Wall Pool. And we'll mention that a little bit later on and with respect to another event. But we could see the deposits of these rocks. They're deposited all over here. And it seems that the main focus of this explosion went towards this river located over here called the Firehole River. So fortunately for the people on the boardwalk, it didn't explode in this direction. Instead, it exploded off into this direction. And so most of that rubble was deposited up over here. By the afternoon, though, there were additional bursts of hot water that reached about 8 feet in height. So we were seeing kind of a fountaining effect that was happening out here from time to time. So why did this happen? Why did this happen at this location? Could it just be because they're just geysers out here? Well, it's a little bit more sophisticated, and so I wanted to spend a little bit of time for those that have a desire for some in-depth understanding of what happens at Biscuit Basin. It's pretty fascinating. In order to understand what happened out at Biscuit Basin that day, we need to understand how geysers and hot springs in Yellowstone work and function generally. And most of what's happening out there is due to heat flow coming from shallowly buried young rhyolitic rocks. So remember, rhyolitic rocks are rocks that are volcanic in origin. These are very young. They're actually still very hot. We'll get into why they're still very hot. So there's a lot of heat flow coming off of these rocks. And above them is a significant amount, in this case, in this cross-section, they're going to use the example of 400 feet of glacial gravels. This is material brought in during the ice ages, during periods of time when there's glaciers moving across the area. These glacial gravels are deposited across the top of the rhyolite, and they're porous, and water is able to move through it very effectively, especially given that there's rivers nearby. So there's a constant water source pulsing water across the top of this rhyolite. And so what happens is we have the rhyolite, which is very hot down here, and then above this we have the glacial gravels, which are almost like ice cubes. You pour water into a glass and fills up with water, and the water fills in all the pore space. And then at the top is the land surface where the eruptions or the explosions in the case of Black Diamond Pool occur. In the case of a geyser, so a geyser is a spring characterized by an intermittent discharge of water and steam ejected turbulently. In other words, it's exploding out. And the plumbing has constrictions. So when we look at a geyser, we can think of a geyser over here. The water is moving along this contact between the glacial material and the rhyolite somewhere much deeper. The water is getting superheated. In other words, it gets well above 100 degrees Celsius or 212 degrees Fahrenheit. In other words, the boiling point at which we would see water boiling at the Earth's surface at sea level, and this is going to play a major role in some of the slides coming up. The reason why is because when water is put under pressure, and as you stack water down within the Earth, it goes under pressure. In fact, it adds another atmosphere every 10 meters of depth. So 10 meters is approximately 32 feet, 33 feet, something like this, if I can remember. Over here we have a scale. So every single time we go through, 100 feet, that's 3 more atmospheres of pressure that are added. And what happens when we add pressure onto water? What happens to its boiling point? Well, the boiling point actually moves up. So you can get water extremely hot. In this case, at 400 degrees, 400 feet, you can get temperatures of 356 degrees and the water is not boiling. 180 degrees Celsius for those of you that use metric. So what happens as the water makes its way up into the system? Well, at some point it hits a level where it will boil. It'll start to transition, and you'll start getting bubbles that will form within the water. And within that plumbing, within these little constrictions that we're seeing here, you'll get an accumulation of bubbles. Those bubbles will start to expand and accumulate over time, and then eventually the entire system will blast the water out. It'll erupt it out to clear that bubble out, and then what will happen is the cool water will come back in, it'll reset the entire system, and it'll start to build up that heat again. Those constrictions are what cause the bubbles to get trapped and to clear out. In hot springs, it's a little different. The superheated water rapidly circulates to the surface. It's constantly roiling its way back up. It's coming back down. Well, not always roiling. Roiling means to have turbidity in it, but the water is moving up towards the surface. It's coming back down. And that clean transition of hot to cold water, that circulation, prevents the eruptive temperatures from occurring. And the plumbing, generally speaking, has few or no constrictions. Okay? So that's how geysers and hot springs in Yellowstone, for the most part, work in terms of as a physical behavior. So what is Black Diamond Pool? Is it a geyser? Is it a hot spring? Well, it's a pool. It's a transmission zone for water moving through the area. It does have an interesting history. We will talk about it briefly. But Black Diamond Pool is a large, murky pool, a blue pool with water flowing into other pools nearby. So it's picking up groundwater, it's coming in, and if the groundwater gets high enough, it'll actually let that water come out across the top. That water will flow over into the Firehole River. It'll drain into Black Opal Pool, or it'll rise up and just simply transmit that back through groundwater back into these areas where it will discharge again through underwater springs, but it'll wind up in the Firehole River both ways, either above or below. The water in Black Diamond Pool is about 149 degrees Fahrenheit on average. That's 65 degrees Celsius for those of you that love the metric system, and has a pH of about 8.2, which means that it's alkaline in nature. You frequently hear about a lot of these geysers having acidic water, and that they dissolve things because they're acidic. Well, in this case, it's alkaline. That doesn't mean that it's not a problem if you get some of this on you. Outflow from the pool forms braided channels containing orange and green thermophiles. In other words, here we see the orange, and here we see green, and we see it in the outflow coming out over here. Those thermophiles, which means thermo meaning heat loving, right? Talking about bacteria and organisms that live in there that have that coloration and gives it that distinctive aerial photograph that we're seeing right here. By the way, this is what we were talking about earlier. This is where the explosion, of course, happened. Here's the parking lot, and those that were running on this boardwalk had run in this direction to get away towards Sapphire Pool. I'm pointing out Sapphire Pool because Sapphire Pool has an interesting history that is very similar to what we might be seeing over here. And so it kind of starts to open up the situation in terms of clues of what might be happening. So now that we know a little bit about Black Diamond Pool, and the fact it has 149 degree Fahrenheit water, which is 65 Celsius, we can compare that information to what we're seeing at other hydrothermal sites in the area, which didn't explode, right? And so when we look around, we recognize that to the west here, located right here, is Sapphire Pool. It has a temperature of 200 degrees Fahrenheit, which is 93 Celsius. This is actually very interesting because remember we just mentioned that the boiling point of water is highly pressure dependent. In other words, as you go down into the Earth's surface, the temperature goes way up. Well, as you get up to the Earth's surface and move above it, it goes down. So we're sitting here at 7,200 feet elevation. The boiling point of water is 200 degrees Fahrenheit, not 212. And for those of you, again, that love the metric system, 93 degrees Celsius. So at 93 degrees Celsius, water boils. So Sapphire Pool has water at the boiling point right here at its surface. Okay, so this is as hot as water gets before it turns into steam. Mustard Spring, which is located right here, 198 Fahrenheit, which is 92 Celsius. It's 1 degree, right? Basically 1 degree, maybe 2 degrees away from boiling. Avoca Spring, 199 Fahrenheit, which is 93 Celsius. So it's right on the cusp at all times. Jewel Geyser is 199 Fahrenheit, which is 93 degrees Celsius. So all the hydrothermal features that we're seeing over in this area are extremely hot. They're hotter than what we're seeing over in Black Diamond Pool. Does that play a role in why it exploded? May or may not, right? But we might have a hypothesis we can glean from this. So as a geologist, we should look at the rocks that are being formed around these geysers and around these hot springs to see if we can figure out what is also happening in the subsurface there. So we brought up the name of the rock that's being formed there. Currently, it's a very young rock. It's called Geyserite. Geyserite is also called siliceous sinter. It is a form of opaline silica, which means it is amorphous. It means it doesn't have a crystalline structure to it at all. And it's hydrated SiO2. So it's not quartz, though it has chemical characteristics that can be a little similar to quartz. It's very hard, for example, in terms of a physical characteristic. That is often found as crusts or layers around hot springs and geysers. And it precipitates where hot alkaline water laden with dissolved SiO2 cools down. So this hot alkaline water, which we talked about before, is coming up from the rhyolites down deep below. And remember, rhyolites have a large amount of SiO2 within them. So that's where the water is getting it from. And it will precipitate geyserite when it cools down. Here we see geyserite in the form with these biscuit structures, hence Biscuit Basin. That's where the term comes from. The waters that precipitate Biscuit Basin's geyserite are meteoric waters. In other words, this is water that doesn't come from somewhere deep within the Earth's mantle or from some other location. It's coming from rain and snowmelt that is finding its way through pore spaces in the groundwater system and making its way down so close to the rhyolites that it picks up that temperature, that heat. They circulate deeply and attain the hottest subsurface temperatures of any fluids in Yellowstone. So you're dealing with a very special set of circumstances when you're talking about the geyserites at Biscuit Basin specifically. These waters, they contain gases that are dissolved within them that are incorporated from degassing of the underlying magma chamber, which is, say, the rhyolites are degassing, in this case, methane and hydrogen chloride right into the water. And so this is something that is being produced, and this is what we're seeing coming out of the geysers and the hot springs, including effectively the pool that is Black Diamond Pool. Now, this hydrothermal explosion that occurred, a lot of people felt was an unprecedented event. The news went crazy with it. Well, it turns out these events happen more often than people think. Most of the time it happens out in the middle of nowhere. If there's not somebody there to see it, then it kind of didn't happen. It's in terms of how the media perceives things. But let's just look at the history of what's been going on in this little area of Biscuit Basin that people visit all the time. In 2009, a smaller explosion occurred in Walpole, which adjoins Black Diamond Pool. So it's right next to it. In fact, this is Black Diamond Pool right here, and here's Walpole. This is the actual photograph of the explosion that occurred in 2009. It's smaller, right? So does that tell us that these pools don't explode from time to time? In fact, scientists will say that the reason that the holes are there in the first place, the pools themselves, are formed from explosions. And that's one of the key parts of looking at Yellowstone, and we're going to come and look at how big these explosions can get. But here we see one coming out of Walpole. Here's Black Diamond Pool right here. Avoca Spring. Remember we mentioned Avoca Spring? This is the spring on the western portion of Biscuit Basin. That spring became an active geyser after Hegen Lake earthquake that occurred in 1959. It was a magnitude 7.2, one of the largest earthquakes in U.S. history, and I believe it was the fourth largest ever measured up to that time in 1959. Sapphire Pool, which we've been talking about, switched from being a pool to a geyser after that 1959 earthquake. So these are very seismically sensitive structures. So the spring became a geyser, and then the pool became a geyser. Major eruptions in Sapphire Pool reached 150 feet in height. By 1968, however, Sapphire ceased to function as a true geyser, returned to being a pool. It still will occasionally violently boil and surge. So these features can switch and alternate from being geysers to being pools, to being geysers to being pools based upon earthquake activity that's happening here. So, of course, the question that has to go through your mind is, did an earthquake occur? Just before we get into the question whether an earthquake occurred there, I want to talk about the Hegen Lake earthquake. Again, magnitude 7.2. It was located just to the northwest of Biscuit Basin. And these are photographs from 1959. This is where the fault actually, this is Lake Hegen right here. And we can see where the fault absolutely dropped these roads and structures and homes right into the water. People were killed in this event. So when we pulled up the USGS map for looking for seismic activity in the area before and after, remember this happened on the 23rd, I pulled up the map for July 19th through the 26th, so a few days after and a few days before. Turns out no magnitude 2.5 or larger earthquakes were recorded in the area during the days prior to, during, or after the explosion. So here's Biscuit Basin, and notice there are no epicenters mapped anywhere on here. So this is a very seismically quiet period of time. From this, scientists can infer from this that active faulting had no part in causing the explosion, which is to say, no earthquakes, right? So the explosion occurred for reasons other than an earthquake. It's not that all of a sudden Black Diamond Pool is suddenly becoming a geyser, for example, as we had seen with Sapphire Pool. The lack of earthquakes also suggests that the caldera, which is to say Yellowstone's major volcanic edifice, played no direct part in the explosion. It plays an indirect part because it's the source of the heat, as we'll show here in a couple of slides. Now, it doesn't take too much time for you to open up a Google Earth image and start looking at Yellowstone Lake and some of the other features around to start noticing that these hydrothermal explosions are probably more common than people realize. Not just the one in 2009, but it turns out they are happening pretty regularly, and sometimes they're quite large. One of the great places to get an idea where this is happening up is at Mary Bay. Now, we'll get into what Mary Bay is here in a minute. Right next to Mary Bay is Indian Pool. And here we have, again, a loop that's coming by that a lot of tourists will use. And this is, in fact, the crater from a hydrothermal explosion that occurred. To give you a sense of scale, there are vehicles down over here, and it blew this entire thing up. This is something much, much larger than what happened over in Biscuit Basin. The Biscuit Basin event would have been just a little pinprick, maybe the size of this bus, for example, right here. When we look over at this image here, this is right here. This circle is this circle right here. But it also turns out there's another one, and it's so large that if you don't look for them, you'll miss it. It turns out Mary Bay is in itself a hydrothermal explosion crater. It's about 1.5 miles, possibly up to 2 miles wide. It's a very large structure, and it's right here, but it just happens to be partially covered by the lake, right? And so we see other little craters over here that are largely filled in, that don't have a whole lot of water in them. But again, former hydrothermal explosion sites that we're seeing here. This thing is about, again, 1.5 miles across. This one here is much, much smaller, but you can still tell you would not want to be near this thing when it exploded. The Mallard Lake Resurgent Dome is the main source of heat for what's happening at Biscuit Basin. So when we look over here, this location right here is that dome. That dome is formed by a hot spot that is underneath North America that is pulsing a large amount of heat up into the lower part of the crust. And as it rises up through this, basically this basaltic magma is rising up. Think of the black lavas that you see in Hawaii. Those are basaltic. And what they do is they intrude it to a certain extent, and then they start to partially melt, and they separate off a rhyolitic partial melt material. And it creates a blister. That blister creates the uplift or the dome that I was talking about earlier. It turns out that Yellowstone has two of them. There's Sour Creek Dome, located up over here, which is a resurgent dome where it's starting to push up. And then we have over here the Mallard Lake Resurgent Dome. This green area right here is where those alkaline waters, laden with a lot of chloride, and because we talked about the chloride coming in off the magma source down below, is coming in over here. The silica is, of course, being pulled out of the rhyolite through an erosive dissolution, which is happening down in depth. And this is the geological context that we're seeing here. And then when we look at this diagram here, you can see they're drawing the geysers up here to show that we have that uplift. But notice that the hydrothermal activity rims or rings this area of the resurgent dome. So clearly, indirectly at a very minimum, the heat source is connected to this resurgent dome, and that is what's causing the explosions. Now, of course, what is happening down below that might have made this suddenly blow up? Well, it could have actually have been a collapse somewhere in the plumbing. It could have also been the fact that we have a large amount of deposition. Remember, as water goes from hot to cold, it'll deposit that silicon, that silicious opal that we were talking about earlier, that Geyserite. And if it clogs the system down below, it might have to explode to blow that stuff back out. There's a lot of possibilities that are happening over here. None of them are easy. What we do know for sure is it's not volcanic in nature, and it's certainly not related to an earthquake. I hope you enjoyed this. I had a good time putting this together for you. Whenever you're talking about Yellowstone, people really get excited. You don't need to worry about this thing exploding. This is something that happens all the time. All the time. I think one of the things we need to, as people that are interested in geology and people that are interested in making these tourist areas available for the public to come out and learn and to explore and to experience these things, is we need to learn from these experiences to keep boardwalks a little further away, because every once in a while these pools might decide to explode. Just something that we have to kind of bake into the cake when we're designing these things. Thanks for following me, and I hope you have a great day.